Screens are flickering. Pilots are losing GPS. Nobody knows why. The answer is 93 million miles away and heading straight toward you. This is a solar superstorm. No warning. And it could set civilization back by decades. Solar storms have happened for billions of years. Humanity is only now truly vulnerable because we surrounded ourselves with the one thing they destroy: electricity. The sun fires a massive cloud of plasma called a coronal mass ejection, up to 2 billion tons moving at 3,000 kilometers per second. It does not hit Earth once, it hits 3 times. Light arrives in 8 minutes. Radiation follows in 60 minutes. Then the plasma wave itself. Think of it like a bomb. Flash first, then the shock wave hits you, then the shrapnel arrives. Each one is more destructive than the last. When plasma hits Earth's magnetic field, it drives enormous currents into power grids worldwide. Scientists call these geomagnetically induced currents. They do not just trip breakers. Those currents burn transformers from the inside, like a defibrillator at maximum power. They destroy. The world has roughly 2,000 large transformers total. Each takes 12 to 18 months to manufacture and install. No stockpiles exist. No rapid replacements. Lose enough at once and darkness lasts over a year. 1 year without power, no refrigeration, no clean water in most cities, no hospital intensive care, no heat in winter. That is the real scenario. But wait, we have already been through this. September 1st, 1859. Richard Carrington was sketching sunspots at his private Red Hill Observatory in England. A blinding white flash erupted on the solar surface. He checked a lens. All fine. He had just witnessed the most powerful solar flare ever recorded. 17 hours later, plasma hit Earth. Wires across Europe and North America erupted in sparks. Paper caught fire. Operators received shocks from equipment they never touched. The Carrington event spanned every continent: Europe, Australia, Asia. Same fires, same sparks, same aurora. Colorado miners woke at midnight thinking it was dawn. Here is the part that sounds like fiction. Some operators disconnected their batteries. The machines kept working. The storm itself was powering the telegraph lines. In 1859, the most complex electrical system was the telegraph. Today that includes power grids, GPS, hospital equipment, banking networks, and the entire internet. The 1859 event lasted 2 days. Telegraph networks took weeks to fully restore. There were congressional hearings, but no regulations came from it. Sound familiar? What happens when a Carrington-scale storm hits today? We actually know the answer. We have seen a smaller version play out. In Canada, 1989. Here is the surprising part. You do not need to imagine this. We have seen it. March 13th, 1989. Quebec, 2:44 in the morning. Instruments at the Hydro-Quebec Control Center went completely off the scale. Engineers had no protocol for this. 92 seconds later, the entire province went completely dark. The Quebec failure cascaded across 6 power systems in 2 minutes. What engineers built over years collapsed faster than anyone could type a single emergency command. 6 million people without power, no heat, minus 20 Celsius outside, 9 hours of complete darkness. And this was not close to a Carrington-scale event. Scientists estimate Carrington was 10 to 20 times more powerful. A Carrington hit today would destroy transformers across entire continents at once. Replacements take 18 months. Think about your typical day: your phone, your commute, your bank, your grocery store. Everything you rely on requires electricity flowing continuously without a single interruption. The failure would not stop at the grid. No electricity means no water. No GPS stops aviation. No banking freezes supply chains. Everything collapses in sequence. On the International Space Station, the crew does not wait. When a major storm warning hits, they move immediately to the most radiation-shielded module on board. Satellites face even more exposure. In October 2003, the Halloween storms damaged dozens, rerouted airlines from polar paths, and disrupted GPS worldwide for days. Satellites do more than GPS. Banking, air traffic control, and power grids all rely on satellite timing. Lose enough and ground systems start cascading down too. Here is where it gets genuinely terrifying. July 23rd, 2012. A Carrington scale CME tore through our solar system. It missed Earth by 9 days. NASA scientists only figured it out a month later. Baker estimated a direct hit would have caused $2 trillion in damage. Not billion, trillion. But that near miss is not the most unsettling part of the story. For that, go to a Japanese forest and look inside an ancient cedar tree. In 2012, Fusa Miyake published a landmark paper in Nature. She found a massive carbon-14 spike in tree rings dated to 774 AD. That spike is a fingerprint of a solar superflare, beyond all modern records. It happens once every 1,000 years. The last, 1,200 years ago. Tree ring spikes from 774 appeared across Japan, Europe, and North America. The event was clearly planetary. Nothing in the modern record even comes close. The cedar tree changed everything. The sun had already fired an event beyond all modern records. And global infrastructure was built, assuming that was impossible. Here is a paradox nobody mentions. Renewable energy should make us safer. But longer transmission lines make power grids more vulnerable to solar storms, not less. Undersea cables connecting continents are vulnerable to induced currents. A major storm could physically sever internet links between North America, Europe, and Asia simultaneously. NOAA watches the sun around the clock. When a large CME is detected, scientists issue an alert. The warning window is 15 to 60 minutes. That is a fire alarm sounding when flames are in the hallway. 15 to 60 minutes to shut down grids, reroute satellites, and protect critical systems. That window is workable if the protocol exists. Power down key grids, safe mode satellites, move hospitals to generators. The plan must exist before the storm hits. Here is the gut punch. We know how to fix this. GIC blockers shield every transformer. Cost to protect the U.S. grid? 10 to 30 billion. Compare that to Baker's $2 trillion damage estimate. 1% of potential loss to prevent it entirely. The technology exists. Protection is still not complete. European grids face the same transformer vulnerabilities. Lloyd's of London estimated global damage from one major solar storm at several $1 trillion. This risk is worldwide. The barrier is not technology, it is inertia. No catastrophe has happened yet. And historically, we only fix infrastructure systems after they break, not before. May 2024, Earth's strongest geomagnetic storm in 20 years, G5. Northern lights appeared over Florida and Europe. Beautiful to watch, alarming to understand. We are in solar cycle 25. The sun peaked in 2024, earlier and stronger than NASA predicted. The cycle runs through 2026. Cycle 25 has already produced multiple X-class flares. It is not over. Activity stays elevated through 2026. Every month of peak activity is another gamble. Remember that control room from the opening? The difference between disruption and civilizational collapse is not technology or money. It is timing. It is 9 days. We built civilization assuming the sun would behave. It never agreed. We have warning systems and solutions. The only question is whether we act in time. If this changed how you see the sun, like, subscribe, and share it.